This video I would like to introduce you a very nice problem. Here is the following setup. We have x and y as natural numbers such that we have these two conditions satisfied the setup. First of all, we have 1 is inferior to x and x is inferior to y and y is inferior to 1001. Okay? The second condition, we have the sum of these squares xy plus y squared is a multiple 49. In the other word, 49 divides the sum of these natural numbers. Our goal, we are not going to solve this equation, but we are going to determine how many pair of the solutions that we have in order to solve this equation. Okay? So by the way, I'm going to give you a small hint that you are going. So let's jump into the solution. So we are saying these two terms is a multiple 49, which means we have x squared plus y squared equals 49 is multiplied by m, where is m is some natural number. Okay? Notice here 49 is a 7 square. Okay? This 49 equals 7 square, which means this sum of these integers is a multiple of 7 as well. Okay? So which means x squared plus y squared equals 7 is multiplied by m prime, like this. Okay? So by using the congruence definition, this one equivalent x squared plus y squared is congruent to 0 mod 7. Okay? So I'm going to go through the quick chart to see where we have a perfect square. Okay? Mod 7. By using this chart, we will have these following values. For example, we have n squared mod 7. Okay? I'm going to take a certain values of n. Let's check 0, 1, 2, 3, 4, 5, 6. For the first term, we'll have 0 square 0, 0 square which is 0, 1 square which is 1, 2 square which is 4, 3 square which is 9. 9 is the same as 2. Is congruent to 2 mod 7 because 9 is 2 more 7. 7. 4 square is 16. 16 is the same as 2. It's congruent to 2 mod 7. So for 5 square which is 25, we have 4 more than 21, which is 4. For 6 square, we have 6 square which is 36. We have 6 square which is 36. 36 is 1 more than 35, which is multiple of 7. Okay? Which is 1. For 7 square is the same as, because 0 is 0 congruent to mod 7, because 7 divides 7. Number 8 each square which is 64. 64 is 1 more 63, which is 1. So if you take a look at here, with the 0 and 1, it started repeating. Okay, so we are going to stop here. So I'm going to check what's the values of the perfect square we found, mod 7. We found 0, 1, 2, and 4. Okay, are perfect square mod 7. Okay. Now we are not looking for the perfect square. We are looking for the sum of the two squares. Okay. If I'm going to add them together, they give us a multiple of 7. If you found the sum of these squares are multiple of 7, so which means we have this mean is a solution for this equation. Okay. So if adding 1 plus 4 is not multiple of 7, 1 plus 4 is 5, 5 is not multiple of 7, 4 plus 2 is 6, 6 is not multiple of 7. The only two sums we can find a multiple of 7, which is 0. 0 plus 0 is congruent to 0 mod 7, which means 7 divides 0. Okay? So this one is telling us x squared plus y squared is congruent to 0 mod 7. Okay? This one implies x squared is congruent to 0 mod 7. Okay, and also y squared is congruent to 0 mod 7. Since x squared is congruent to 0 mod 7, which means x is congruent to 0 mod 7. Also y is congruent to 0 mod 7. Okay? This x is a multiple of 7 and y is a multiple of 7. In the other word, x equals 7 is multiplied by q1 and y equals 7 is multiplied by q2. Okay? Since we have x is inferior to y. X and y is a pair of the solution. So we have 7 and 7 is the pair of the solution. That's this one. This is column number 1. For the second, this is the first possibility. If you have only one column. The second possibility will have 7 and 14, because we always have two numbers. X is inferior to y. If we put in y equals 14, x equals 7. So this is the second possibility in the second column that we can have. And then the other one will have 14 and 14. Okay? The second column. Because x it could be equals to y, or x is strictly inferior than y. That's what happened here. 7, 14, 14, 14. For the third possibility, as a third column, so we will have 7, 21, because 21 is a multiple of 7, and it will have 14, 21, and 21, 21. Okay? This pattern is keep going all the way down to the n columns. So I'm going to check how many pair of the solution we have in this interval. We cannot exceed 1001. So if you take a look carefully, 1001 equals 143 is multiplied by 7. So which means we have 143 pair of the solutions. It can be in the last column. Okay? So I'm going to replace this n with 143. So which means I will have the first solution 7. The last one is 1001. The second one is 14,001. And all the way down until you get the last pair of the solution, which is 1001 and 1001. Okay? So which means the pair of the solutions, the sum of these columns. Okay? So that means the number of the solution, the number of the pair of the solutions that we have, the sum of these columns. Okay? So I'm going to add them together by adding 1 plus 2 and all the way down to the 43 column. For the first column, we have only one pair of the solution, which is 1. For the second column, we have 2. For the third column, we have 3. This one is keep going all the way down until you get the last column. The last column has 143 pair of the solution. So there is a very famous and known formula for this one. Is a triangle identity. So this one is the same as n is multiplied by n plus 1 is divided by 2. Is n is multiplied by n plus 1 divided by 2. N will be replaced with 143 is multiplied by 143 plus number 1 is divided by 2, which is 143 is multiplied by 144 over 2. 144 over 2, which is 72, is multiplied by 143. This is the number of the solutions that we found. Okay? X squared plus y squared, by summing these numbers, x squared plus y squared equals 7 squared is multiplied by k1 squared plus k2 squared, like this. Okay? Finally, we have found, this is the number of the pair of the solutions that we found. So I have done this problem. If you have any question or suggestion, just put it in the comment section below. Thank you for watching. I will see you in next video. Okay?